Hi everyone, welcome. Thank you for joining us today. I'll wait for a couple seconds for everyone to join. And on the meantime, just to like a quick round of intros. Today I'm here with two very special guests. It's the first time we have actually two of our leadership team members out apart from Ali on this leadership series event. So very excited to welcome Imran and Andrew. I'll let you guys both do like a quick introduction and then we can get started.
Awesome. Yeah, well, thanks for that, Sophia. Great to meet everyone. I'm Imran, VP of Research, leading the Cortex lab here at micro1. A little bit about myself. My background is in applied mathematics. I did my undergrad Maths and Physics, PhD theoretical physics. I did my postdoc at Harvard, and then I spent several years in IBM across research and technology divisions. Additionally to my role at micro1, I'm a visiting assistant professor in the Department of Mathematics at the University of Surrey, and I also sit on the advisory board at the Isaac Newton Institute of Mathematical Sciences at the University of Cambridge.
Thank you, Imran. Great having you here. Andrew, do you want to go for it?
Sure. Hey, everyone. My name's Andrew Maas. I'm VP of AI here at micro1. In practice, that means I spend a lot of time thinking about for different projects and different types of datas, how do we effectively pair our machine systems and user interfaces with our experts, all of you, in order to build the most valuable data, the highest quality data, the most consistent data. My background is in deep learning research. So I actually started a PhD way back when all of these deep learning models were in very nascent forms back in 2009. And so I've seen the evolution of data sets, what type of feedback and training and input we need from humans, and the progression towards more and more expertise. So after finishing my PhD, I actually started a company that was enabling healthcare experts to sort of supercharge their ability to sort through a lot of text medical records or doctor notes or pharmaceutical information. And you would build that type of company very differently today in the era of LLMs and increasingly LLM-based agents. And so here at micro1, I'm pretty fascinated by a lot of the research questions that all of you are a part of by using your expertise to evaluate systems and give them feedback, which is part of this sort of grand iterative process that we've now been undertaking for over a decade, and it's really taken off over the past couple of years in terms of how much we can sort of leverage human expertise in order to train systems to do pretty complicated stuff.
Thank you, Andrew. And you gave me the perfect intro to just like a quick disclaimer to take advantage of Imran's and also Andrew's knowledge. I've selected the most like technical and interesting questions, like Andrew was saying. So those are the ones I shared with them previous to our sync here with everyone. And then left all of the other questions that we usually cover in other sessions, whether it's leadership sessions or other types of events to cover in other places. So that being said, I'll start with the questions that you all submitted on the form and hear from these two great leaders we have at micro1. That's good. Okay. All right. So the first one they asked is if you're seeing a faster adoption from enterprise deploying AI internally or from AI native startups, and how does that shape our approach at micro1?
That's a great question. So I would say overall we're seeing a stronger pull from enterprises right now. I think the nature of this is that startups in general are more comfortable iterating quickly, sort of tolerating some failures, but enterprises overall don't have that same tolerance level. They need systems that are reliable, auditable, and predictable really from day one. Um, and I think also, in addition to that, we have seen some uptick in terms of small cap AI native startups as well who recognize this. I think the interesting overall in terms of micro1 strategy is that we're not seeing the bottleneck from a model capability perspective anymore. It's whether these full systems actually work in real workflows. And that's really where Cortex comes in general. So in terms of like the sales motion, it's less about what models one should use, but more about how we can make the system safe and effective in a production environment.
Thank you. That's great. And since you brought Cortex up, the next question was, what do you see as Cortex core defensibility over time?
Yeah, that's a great question. I would say that the core defensibility doesn't lie in a single component of Cortex. Cortex is really the loop, right? So what we're doing with Cortex is we're combining the human expert data, contextual evaluation, and system level optimization into a continuous feedback loop that over time we can generate proprietary data sets, sort of failure mode taxonomies, and deep understanding of how these systems behave in real environments. So I think while what others are doing in terms of like data and tooling, what we're looking at is what compounds in a closed loop system. And that's really the evaluation, insight, and improvement layer that we're building, which will really ground enterprises in sort of real use cases. So I would say overall, the benefits and sort of the advantages of Cortex is not in a single component out of that. It's at this full sort of life cycle that we have at the moment.
That's super interesting. I guess one more question related to Cortex is how do you think about, I think this you kind of just answered, but we can go over it more in depth. How do you think about the full life cycle of enterprise agents from evaluation and training to production and deployment? And also, where does Cortex create the most leverage?
Yeah, another great question. I think in terms of the full life cycle, majority of teams think it's just you train a model and then you deploy it, right? In reality, I would say deployment is where where the real work actually begins. So at Cortex, we think of the continuous loop. We first have to define what good looks like in that particular context because it's very domain specific, right? If you're in healthcare, it may look very different to finance, for example, right? And then the second thing is evaluating the system against sort of evaluating the system's behavior against that, right? So you have to define what good looks like first, then you have to have a way of evaluating the system. And the third component is around identifying, right? So this is that failure mode taxonomy that I mentioned previously. And that gives you the idea of how we can improve that system. So whether it's prompting, whether it's retrieval, whether it's fine tuning, whether it's some other form of system architecture improvements, that really gives us an insight, right? So it's all these four steps. So Cortex creates the most leverage, I would say, in that middle layer. So turning real world behavior into this structured feedback that actually drives improvement over time.
Great. I'll switch gears to some questions for Andrew too. The first one was, what role do experts play once agents are deployed in production, particularly in monitoring performance, fixing failures, and integrating into real workflows?
Yeah, I think actually part of what Imran just mentioned about Cortex is a good example of how the role of experts sort of shifts over time, depending on the system we're talking about, depending on kind of where we are in a deployment lifecycle. And I think these days, as we're talking about building agents, whether it's in kind of an agent first startup or an enterprise, the striking thing is we have a lot of these individual components that are now quite powerful. So the ability to, for example, parse a lot of information out of a PDF document, that works pretty reliably. And so I can kick off a bunch of business processes by putting, logic for my enterprise into a couple of different steps. And now that's an agentic workflow. And what's really cool is we can create a ton of value in the sense that these things work a significant fraction of the time. And even if you, the person who kind of threw that thing together, is monitoring it yourself, you're probably a lot more productive than you would be just trying to execute that type of workflow on your own, right? Now, where the kind of broader role of micro1 experts comes in is when we start to talk about, well, we as a startup want to do tax accounting, or we want to do this particular, regulated healthcare compliance workflow, or we want to do a bunch of, security and penetration testing and review a lot of reports about, the threat surface of a particular enterprise. Now we need people with significant expertise who are reviewing or interacting with these agent workflows. And so that means that you get into this hard to define space about giving feedback on a system versus correcting the output of a system or signing off on the outputs of a system for some compliance reason. Um, as well as maybe intervening if the system is going off the rails, right? We see this with coding agents already. Software engineers are kind of, watching what's happening, and if the system gets into a weird cycle where it's querying the wrong API and confused about how to fix it, you stop it and you reset. And so I think we are just at the beginning of exploring what the equivalent of that is for these enterprise agents. And that's where, like Imran was saying, when we talk about Cortex, the value is in setting up these kind of feedback loops and the ability to pair the human expert with the agents that are either having, recently working and confused or as they're working. And so the exact boundaries of what the agent is doing and how that information is fed back into the system, that's changing a lot as we mature these systems and as we deploy them in different domains. But the pairing ends up just being important over time consistently.
Nice. Imran, do you want to add something or no?
No, I think Andrew summed it up perfectly about the key role is how that expert is defined, so that expert data is defined within the feedback loop. I think that's completely spot on. But yeah.
Nice. Thank you. All right. So the next question, Andre, is how do you balance human evaluation with automated guardrails, and how does that evolve over time?
Yeah, I think there's two things about this that are really interesting to me right now. One is because we have coding agents and sort of LLM-based coding assistants, the cost of generating automated checks is now much lower than it used to be. And this turns out to be really helpful for doing things like consistency checking. There's a bunch of boring stuff that I want to make sure is good about a data set that I really don't want to spend any human's time checking. Because there are things like make sure all of the unique identifiers for, objects listed in this video are consistent over time, right? So the ability to generate, automated software checks is fantastic. And for a lot of that stuff, I think about the human evaluation component as what is the actual thing where I need the human brain the most, right? Because oftentimes, in almost all cases, when we're developing these systems, we're actually limited in terms of how much human brain resource we have access to, right? If I could like spin up human brains the way I spin up like GPU clusters to tell me things about data sets, life would be a lot easier. But it's the case that I design all of these data pipelines, keeping in mind that my human resource is precious and it is way more like fungible in my ability to give it vague instructions or really challenging instructions, especially as we get into things like these, tell me how to fill out this tax form, right? You might have had to train and have a bunch of years experience in order to do that in a sensible way. And so that's kind of the guiding principle of like, where do I want to expend this very precious human expertise resource relative to the automated checks of my pipeline? Because there's so many things that can go wrong about data creation that I have to verify a bunch of things, of course, but with my limited capacity, I want to use that very wisely.
Yeah, that makes total sense. And I think it probably resonates a lot with experts working in projects too, like from their point of view of working on the task and also like the limited amount of experts working on the projects too. Next one is what are the key limitations of contextual evaluation today, and where does it break down? Yeah.
So yeah, I think getting back to that, like, where do you expend your human expertise? There's an engineering sort of science and art around how do I take a human expert and put the right information in front of them so that they can efficiently give me useful feedback relative to what the overall system is doing, right? And so again, like some of what we just mentioned, if I were to put sort of a blank video in front of you and said, describe everything in this video, you will not do it well, right? It's not a task that lends itself to being consistent, to being comprehensive, right? And so um, in that same way, some of the limitations of evaluations or giving feedback to a system is you're looking at the world through that very particular view, meaning if we forgot to give you some piece of context, if you don't know that a particular unique identifier in a record actually corresponds to some huge corporation that has a bunch of history associated with it and specific information about it, then it's very hard, even with your expert judgment, to give the right feedback or give feedback that might take into account what you would say if you had the full picture, right? And so I think the limitations is depending on how we sort of engineer these systems in terms of how we're engaging experts, we end up sort of looking at the world through a straw, and so we have to be very careful that we're asking the right questions in that sense.
Great. Next one, I'd like you both to answer. So it's about what research areas will define the next breakthrough in applied AI over the next 2-3 years. I know it's kind of hard to predict 2-3 years from now in the age we live, but I'd like your take too.
Yeah, sure. Very interesting question. There's a lot that I could say on this, but I think one of the areas that I'm most excited about is a big shift from improving models in isolation to improving systems in context. So I would say around better evaluation frameworks, more effective human AI collaboration is certainly another area that's going to be very important within the next couple of years. And as well as the idea of dealing with long horizon tasks and reliability. I think there's going to be a lot of research areas within those three that are going to be very important, which will have wide-ranging impact. So I think kind of moving away from this idea of like, can a model do this, right? Because very much in isolation, can the system do this reliably over time? And that second question has a lot more research nuance in it than the first one. Everyone's focused on, okay, how can I make this model better by either architectural improvements or data improvements? I think that latter question, which is around what systems can do reliably over time, is a much broader research question. And there's loads of research nuances within that, which I'm super excited to see over the next 2-3 years. But yeah, we'd love to get Andrew's insights on that.
Yeah, I think those are good ones. I mean, I think overall, the most noticeable thing over the next couple of years will be the rapid sort of field deployment or like domain deployment of a lot of different systems. So this is a bit of a tangent, but forgive me. So in machine learning, like when we're building a classifier, like if we want to build basically like GPT-3 or some of the really good like computer vision models, we need a ton of data of the same type because we're building like one module, right? We're building something that takes in an image and creates a description of it. We now have working versions of those things, especially for a bunch of like really critical tasks like creating software, understanding images and videos, understanding text. And so now what we're doing is actually a different type of AI engineering. It's more akin to building robotic systems. So when you're building robotic systems, you're doing what's called a compound AI system, which is like you have multiple steps. Like I need to recognize an image. I need to think about the semantics of like a kitchen. I need to plan an action. I need to then like execute more motor coordinates. And in that compound system, different things can go wrong. And if something goes wrong early, like if you misrecognize like this as, a bowl, oh, you don't see it, it's invisible. I'm holding a mug. So if you misrecognize like an object in the scene, or if your background thing filters it out, right? If I'm holding something invisible, now your robot is screwed because it sees this flickering like mug that's not a mug, and the whole downstream system messes up. Enterprise agents are a lot more like that. than they are like training an image detector. And what's exciting is when you're building these compound AI systems and actually deploying them in the world, it's the domain expertise and like getting it right in terms of like engineering it into how like the business and like enterprise logic works that actually matters a lot more. Like having someone who just says, please collect more data and I'll train you a deep learning model actually doesn't solve any of these kind of like janky multi-step systems. And so I think that over the next like 3 years, actually like applied AI, sort of the research breakthroughs will be in how do we get these things to do like self restarts to catch themselves when they're starting to go off the rails, and to make it so that we actually start like having this new type of partnership between like a system that can go off and run and do a bunch of stuff and come and engage you proactively when it's confused or when it knows that it needs a human decision. Um,
And I guess that also makes them more like trustable for the normal, day-to-day task, like when we get to that point, right? I feel like we're
yeah,
not there
I
yet.
think one thing I didn't say there is like I don't think that over the next 2 years we're all going to be excited about like some particular neural net model is like such a breakthrough over the models that we have today. I think like it's increasingly repeated among my like deep learning research friends that like even if you didn't train another like LLM like from right now forward in terms of like the big base models, there's so much we can do in terms of these like multi-step reasoning chains and the so-called harness, the sort of wrapper I put around my sequence of LLM calls and all the logic around it, so that I'm building a system that's far more powerful. Yeah, I think like we'll see a lot more of that than we're seeing of like this individual component. I think we have such a sandbox of individual components already.
Great. That's a great insight too. Next question is, what role do experts play in AI generated video analysis, and how is micro1 thinking about building capabilities in this area? And I thought this one was very interesting because I heard about like video analysis of actual videos, not like non-AI generated. And now there's also like a bunch of, AI generating tools for videos. And it's very interesting, right? That we can also use those to train models.
Yeah, I think so. Without saying anything about specific projects, I think there are deep learning researchers in the world, there are companies in the world that are interested in both understanding and getting access to like, real world, videos of actual humans doing actual things that are richly described. But then also videos that are generated by an AI model, perhaps with an accompanying prompt, and they want feedback on whether that video fits different types of criteria or different style. Um, I think that second category is especially interesting in terms of the role of micro1 experts, because as our ability to do different types of generative deep learning has matured, you notice that it becomes more a question of curation and taste of the data set, right? So, like, what is it that makes a particular generated voice sound more professional or authoritative versus more casual and friendly? It traces back to the training data that was used for that thing, and some pairing of like feedback or prompting that might come from an expert. And so, as we think about micro1, obviously we have people here who have deep expertise in audio, video, engineering, in mastering and leveling, right? And so as we mature our video generation technology, the hope is that we start tapping deeper and deeper into the knowledge of some of our domain experts to have videos that are generated according to like very specific style nuances, right? We see this already in some of the image generators. You can generate different types of photography effects in a way, or even you can describe like the specific parameters of a camera lens, and I think things like Midjourney would try to basically like sort of synthesize that effect.
Yeah, that's great. Imran, do you want to add anything to this one before we jump on to the next one, or?
No, I think Andrew covered it incredibly well. I don't have anything to add, but I just yeah, re-echoing what he mentioned there.
Great, thank you. I have one more question for you both. I also think there's a couple, or at least one interesting question on the Q&A. We can maybe try to tackle it if we have enough time. So last one from me is, how do you think about ethics of scaling AI systems, particularly around data and evaluation?
Yeah, I think so. Ethics is super broad. I always encourage people to ask more questions about ethics because there's a lot of subtopics. Um, so, in terms of scaling AI systems, I guess like Imram, Sophie, tell me if you have a different way you think about this question. Um, but I think my broad notion is that data sets control the behavior of systems and feedback controls the behavior of systems. And so I didn't kind of go through a full list of like projects that I worked on in the beginning, but I spent some amount of time responsible for labeling data and data quality for self-driving research at Apple. And when you're working on self-driving cars, you're working on systems that if you scale them up in production, they will kill people. It's not a question of if. It's statistically guaranteed once you have a fleet of a certain size that you'll have fatalities. And so then the question becomes like, well, how's it going to happen? And in my mind, I never wanted it to happen because we had a data labeling tool that made it really hard to see like someone who's like half behind a bus. And so there was a bias in our data set as a result of that, where we always missed a particular type of situation. And if you actually look, like there's things you can see about like Tesla fatalities where in one case, they missed in their perception system, like white tractor trailers that were horizontal across a road. And it's like a systematic bias. And so ethically, I think we who are involved in creating the data sets that have this really powerful impact on the systems that we're working on, right? All of us as experts here at micro1 are actually working on some of these very high profile systems in the world. It's good to be intentional and it's good to be sort of aware of a little bit of your role in the process, right? So if, for example, you as a domain expert in healthcare or finance are seeing that the tasks you're working on are totally missing some aspect of a case, and that makes your evaluations, like you're kind of guessing in some way, or you would have a very different opinion, or you could see like raising that as an issue will increase the quality of the data. And I think like that does, when we talk about some of these high stakes domains, that does border on being like an ethical issue, right? It's like, uh, always in startups, I like the motto, if you see something, say something, which is like things are often moving fast. We're working on a lot of projects. And so if something seems weird to you, especially in your expertise area, flagging it and saying like, hey, why is it this way? Might reveal that you're the only person that has noticed this so far.
I think this is great. Like you brought up a lot of very interesting points. Not only, I don't think like it's only for experts, but even like internal micro1 team and like I don't know, like just myself. I feel like it's been great learning too. But Imran, curious to hear your take here too.
Yeah, I think as Andrew said, ethics is really, really broad. I think one of the areas is instead of like shifting where we think about scale alone, we're starting to think more about quality and accountability at scale as well. So sort of being intentional around how our data is sourced and labeled, ensuring systems are evaluated in the actual context that they're being used in, I think is a real big one as well. And just looking at making these failures detectable and understandable, right? I don't think there's probably enough high quality data sort of out there. We're definitely going to need more, but I would say the focus is now going more towards better structure, and more representative data rather than just thinking about volume alone. Like, if we think about how initial ChatGPT was trained just on the entire internet, I think that's definitely shifted in terms of where we see things moving forward.
Nice.
Yeah.
All right.
Data
If you
diversity is a big piece of like not being biased in the final system, right?
100%.
Nice. Okay, I think I overpromised. So if you guys have like one more minute, I think there's only two questions, but at least let's tackle one. So I'm not unfair with my previous statement. But Andrew, what do you think about this one? Somebody, Ryan, he posted on the chat, as human intelligence and experience is being used to train models, would rehearsing the training so that the execution has less error or variations? He said like more signal, less noise, optimized training, or would there be too much bias on perfection with that? I think this is very interesting for you to answer.
So there's a balance. I think this question, if I understand correctly, is about sort of how much do you want sort of broad examples in your data set that might show you different types of behaviors versus having like, here's the one perfect way to do a thing. Um, so this this is actually different for different parts of your system. So again, if I'm building one of these like multi-step like AI like robot type systems, I might want a ton of variability in my data about perceiving the world because I want to kind of be prepared to encounter lots of different scenarios, right? So I might want a very broad training distribution. And if I have some noise in my labels, that might be less important than just making sure that, for example, I can recognize objects really well in the nighttime, in the daytime, in the bright sun, and all different types of geographic environments and so on. Now, when we're talking about like imitation learning, or if I want to learn the multi-step procedure again for like filling out tax forms or working through a differential diagnosis in healthcare, I don't really want every random person in the world to give me demonstration data for that and have my model try to figure out the sort of right the median of a bunch of non-experts or like a bunch of like low quality mixed in with the expert is actually hurting me. And so for things where we're talking about deploying an agent that's doing some complex multi-step workflow, usually we're more interested in a small number of highly precise examples, and then we let the system try to generalize in ways that it thinks are safe versus this kind of like very broad scattershot of like mixed quality, right? And so I think as we get into basically more complex, like multi-step tasks, we get more interested in, is this kind of the optimal set of intermediates, or is this, pretty close to what a human expert working through the same problem, even if it took them a lot more time, or they did it in a slightly different way, they would achieve the same intermediate steps.
Great. And I think just to wrap it up, there's like a kind of follow-up question related to this, but how would you determine, or how can we determine the appropriate amount of training data required to ensure that like it's sufficient and robust and reliable in like when you apply it into the real world? I think Raymond, this is what you wanted to get answered. So
I'll say Imran answered this question earlier in a way, which is I I think like in machine learning we have classical like heuristics about like training data. Again, like those are for building these like classifiers, right? So like, well, you need like 1,000 examples to build a decent classifier. That doesn't really apply to a lot of this when we're talking about building like a multi-step agent. Even when we're talking about using an LLM, I can now do few shot, which means like I just describe to an LLM 3 examples and I get a halfway decent classifier in some cases. And so what we're seeing in terms of the amount of training data or feedback, again, I think of this as like basically hours of human domain expertise and how am I going to pair that with my system? And it turns out that like these things are, this is why Cortex is, I think, what it is in a bunch of ways, because the way these systems are evolving is we want to pair the human expert with the system at evaluation time or as it's getting deployed, because inevitably there's some adjustment. And so even if I've trained my individual components on millions or billions of examples of like processing images and things like that, when I go and I hook up a particular multi-step workflow, there's going to be maybe something a little weird, a little unexpected. And so that's where having small amounts of human feedback on the live system can actually help the system adapt, or if nothing else, help flag that there's a problem for us to go and do a rebuild.
Imran, were you going to say something?
Yeah, I know we're over time, but just kind of one point
Yeah,
on this
wrap
one
it
and one
up.
point
Yeah,
on the
yeah.
previous one. But yeah, I completely agree with what Andrew's saying. In terms of training data and data as a whole, in practice, what you kind of want is what I define as like structured realism. So you want high quality, well-defined signals of what good looks like, but at the same time, you want to have coverage of real world variation, right? Because real world environments are messy. People hesitate, interrupt, make mistakes, etc., etc. So if you can try and build a corpus around that, I think you're going to have better generalizable performance than training on something very idealized, right? So you have some type of very clean distribution, but then when you actually deploy it in the real world, you see it's all messy, and then you get these sort of distribution shifts in what you actually are getting, right? Which is a big deal, big issue.
Awesome. Well, thank you both so much for your time and staying a couple minutes over. I think it was, at least for me, it was very interesting. I think I could hear you both talk for a couple hours at least. So thank you for taking the time. And also thank you for everyone that joined from all over the world. From what I saw in the chat, I think everyone's on quite different time zones. So really appreciate you all being here. And we'll post the recording anyways for all of those that couldn't join live, so everyone can learn as much as we did.
Oh, thanks everyone.
Great,
Thank you
thank
so
you.
much. Bye.